Okay, so we'll be getting started now. Before we get on to new material, does anyone have any questions about what we covered before? Well, I know I put day 3, but it's essentially the third meeting. So what we'll go over today is linear equations. So what a linear equation is that we've gone over variables before. So if x is our variable, then a linear equation would only have the term x and a constant, which is a number like 5. So 3x minus 5 equals 7 is linear since it only contains x with a coefficient and constants 5 and 7. So 3x equals 7 times 5. However, if we had something x squared, which is x times x equals 3, this is not a linear equation. So if we had a linear equation such as this one, what we would have to do here is to divide by 4 on each side since x has a coefficient of 4, and thus 4x divided by 4 is x, 16 divided by 4 is 4, so x would equal 4, which is our final solution since we found out what x is, which is kind of the point of the whole solving thing, to find what a variable equals. Similarly, if we were to do x minus 3 equals 7, if we added 3 on each side, we could do x equals 10. Oh, by the way, I shifted one of the lessons backwards. So we're not doing weights today. I said on the syllabus, we're doing linear equations and multivariables first. I will update the syllabus later. Does anyone have any questions on that? If not, could you guys answer 6x minus equals 108 in the chat? Yes, 18 is correct since you would divide 6 on both sides and 6 equals 18. Now moving on to more complex linear equations. If we had, say, 5x minus 3 equals 17, first, as we need to, so we can't divide by 5 immediately, since it would just be weird, since it would devolve into 3/5 equals 17/5, and you don't really want to add fractions. It's more burdensome. So, but you could do it any way you wanted. So what you do first is you add 3 to both sides. So 5x equals 20. And you then divide like we've done before, which gives you x equals 4. Now, if we went with this route, we would get x equals 17/5 plus 3/5 equals 4, which is the same answer. Generally, it's easier to add like terms first, which is this route, but this one works as well. Now that we've gone over that, could you guys answer 7x minus 13 equals 22? Yeah, fractions are a bit disgusting. Yeah, and good job, 5 is correct. You would add 13 to make 35 and divide each side by 7. Now that we have that in mind, 3x minus 17 equals 24 minus 4x. So we have x's on both sides of the equation. That isn't very good. So we need to combine the like terms by adding 4x to each side in order to get one side to have all the x's. So 7x minus 17 equals 24, and we did what we did before, and to get x equals 41/7. So the application of these linear equations that we've gone over so far is that you would obviously solve problems with them. And we'll go over a few now. So for example, let's say we had 3 less than 2 times . Okay, so this is the first time we've gone over the word problem. So we have 3 less than 2 times the number equals 4 times the number plus 8. So whenever we have something like the number or whatever you want to find, like how many books Joe has or the bank account of Bob, you would put X as a value here. So X is the number or a number. So 3 less than 2 times a number. So 3 less than means a number that is 3 less than 2 times the number. So, and 2 times the number is 2 times X. So the left side of our equation will equal 2x minus 3. Then equals, which is an equal sign, 4 times the number, which is 4x, and plus 8, which is plus 8. So we would do what we did before, plus 3 to each side of the equation. And then 2x equals 4x plus 11, and move x's o to the left side. Negative 2x equals 11, and x equals negative 5.5. Yes, it is a negative number. Now for another, I should say this more, but it would help if you guys practice, since the practice will make things better. So each sack of apples at the farmer's market has the same number of apples. Apples are needed to make one of ignore any typos I made in there. So each sack of apples at the farmer's market has the same number of apples, so same number, so that will probably be our x. 7 apples are needed to make one of Mama's excellent apple pies. So one Mama's excellent apple pie would equal 7. I use 3 sacks plus 2 extra apples to make 5 excellent apple pies. So as I said before, each sack of apples contains the same number of apples, which is our x. So 3x plus 2 would be 3x plus 2. I use 3 sacks plus 2 extra apples to make. So 5 of these pies use up 3 sacks plus 2. So this would equal 5 excellent apple pies. Now that we've got that down, so an excellent pie is 7. So 5 times 7 is 35. So each sack, 35. So 3x equals 33. So each sack contains 11 apples. For our final word problem, both surface has a bag for So Pacific had a bag of full dimes and nickels. If there are 3 times as many dimes as nickels and he has $36.05 in his bag, how many nickels does he have? So with questions with money, it's convenient to make this into cents, real money and coins, since coins have cent value. So this is equivalent to 3605 cents, since each dollar is worth 100 cents. Each nickel is worth 5 cents. And each dime is worth 10 cents. Now, Bocephus, he has 3 times as many dimes as nickels. Now, if we were to write an expression for how much money he has, he would have 5 times how many nickels he has, plus 10 times how many dimes he has. Now, since he has 3 times as many dimes as nickels, dimes, so he has 10 times 10 dimes equals 3 times nickels, 5 nickels plus 10 times 3 nickels equals 3605, which if you were to calculate it, he would have 35 times nickels equals 3605. So he has 13 nickels. Yes, 3605 divided by 35. You can enter it into the same equation as before to find out if it's right or not, which I'm doing right now. Wait, no, he has 103 nickels. That's my bad. 3605 divided by 35 is 103. moving onwards. Substitution into linear equations. So to substitute something would be to say, if we had an equation such as 7 minus 4 over x squared equals 5 plus 1 over x squared. So on first glance, this is not a linear equation, since there's an x minus 2 or 1 over x squared. However, if we were to say 1x squared equals n, another variable, then it would turn to 7 minus 4n equals 5 plus 1n. Then there's no fraction there. So we do the same thing with the linear equation. So n equals 0.4, and we can take that back into here. 1x squared equals 0.4, x equals radical 2.5 after you times it by x squared divided by 0.4 and then radical each side. Now that I've shown that, and plus 5 equals could someone solve this equation for 2x3 plus 1? What does this equal? Yeah, that's what's written in the radical. Okay, so we do what we've done before and substitute this mess of an expression into a simple n, and then n plus 5 equals 7n minus n from each side, 5 equals 6n. So we finally get n equals 5, 6 equals 2x3 plus 1. If you wanted to go even further and find x, it would look something like this. Yeah. An interesting problem we can do with this is x over x minus 1 equals 2/3. Wait, that's the one. Plus 2/3 equals 2 over x minus 1. So if you tried what we did before with 1 over x minus 1 equals n, you would get xn plus 2/3 equals 2n. However, this is not linear, so we can't solve it yet. However, x over x minus 1 equals 1 minus plus 1 over x minus 1, since 1 equals x minus 1 over x minus 1. So we have 1 plus 1 over x minus 1 plus 2/3 equals 2 over x minus 1. So x minus 1 over 1 equals 5/3, making x 8/5. Does anyone have any questions on that or anything we've done? So this lesson was a bit short, so I'll move on to the multivariable part of the next lesson. So what essentially more than one variable does is that you can declare more variables to be different things, like Joe's bank account and Bob's bank account. So if say Joe's and Bob's bank account, if Joe and Bob had a sum of $36, then we could use x plus y equals 36. Now that you can do pretty much anything with these two variables as you did with the first pair, about 6x plus 7y equals 279, x squared plus 5y squared equals 29. And this becomes very useful later on when we are forced to have more than one unknown value, which essentially is what a variable is. Well, that will be it for the lesson. So I'll end the Zoom meeting soon if no one has anything to ask or say.